everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem shortest path with alternating colors. In this problem, we are given with an integer n, which represent number of nodes in a directed graph, where nodes are labeled from 0 to n minus 1. And each edge is red or blue in the graph. And there could be self edges and parallel edges. You are given with two arrays, red edges and blue edges, where red edge of I equal to ai comma bi, indicating that there is a directed edge between node ai and node bi in the graph. And similarly, blue edges of j equal to qj comma vj, indicating that there is a directed blue edge from node uj to node vj in the graph. What we have to do? We have to return an array answer of length n, where each answer of x is length of the shortest path from node 0 to node x. Okay, answer of x is the length of the shortest path from node 0 to node x, such that the edge colors alternate along the path, or minus 1 if such path doesn't exist. Okay, so we are basically given with n, which represents number of nodes, and the graph has n nodes, and they are labeled from 0 to n minus 1. And in the graph, the edges can be either one color, red or either blue, and that are given in the form of arrays. And what we have to do? We have to compute answer, which means the length of shortest path from node 0 to all the other nodes, and the path should have alternating edge colors. Okay, so let us take a look at the examples. So firstly, we have n equal to 3. So let me take 3 nodes, 0, 1, 2. And we have red edges as 0 to 1 and 1 to 2. So let me draw them. 0 to 1, we have one red edge. And this is directed graph. So I have represented directed edge between 0 and 1. And then we have an edge from 1 to 2. Okay. So there are no blue edges. So I am not considering anything. So what will be the answer array? So in answer array, what we have to compute is, we have to compute the length of the shortest path from node 0 to node x. So what will be the length of the shortest path from node 0 to node x, such that the edge colors alternate between the path. So 0 to 0 is distance 0, right? We don't have any, so we take 0. And 0 to 1, we have one distance, and we have only 1, so we can consider it. If we have more than 2, then we have to check for the condition if they are alternating or not. If we have only 1, we can consider the distance. So here it will be 1. And to go to 2, we have to, here it is a red edge, here it is a red edge. If we have a blue edge here, then we can consider this condition, but there is no blue edge. Both are red edges in the path of 2. So there is no path with alternating edges. So we consider minus 1. So we return it. Okay. Next, in the next example, we are given with n equal to 3 again. So let me draw the nodes again. And in this case, we are given with red edge from 0 to 1. So let me draw red edge from 0 to 1. And then we have blue edge from 2 to 1. So blue edge from 2 to 1. Okay. Now we have to compute the answer. So what will be the answer? From 0 to 0, the answer will be 0 always. So 0. And then from 0 to 1, the answer will be 1, because the path is 1 only. It is red. So we consider 1. And to go to 2, there is no way of going to 2, right? 0 to 1 we can go because there is an edge, but 0 to 2 there is no edge. Via 1 also there is no edge. So there is no path to go to 2. So we take minus 1 and we return this in the answer. So how can we solve this problem? If we take a look at what they have asked, we have to find the length of shortest path from node 0 to node x. By only looking at this statement, what we can say, basically we have two graph algorithms majorly used to traverse the graph, which are BFS and DFS. if we want to find shortest path, then we always use BFS, because BFS gives the shortest path between two nodes, source and destination. In our case, the source is always 0 and the destination will be all the other nodes in our graph. So BFS gives the shortest path, so we can use BFS in this problem with a special condition, which is the edge colors alternate along the path. So we have to add one more condition to the classic BFS approach. So I will explain this while I code it up. So how we can apply this? So what are the steps in the solution? So firstly, we are given with these edges. So we have to build a graph with all the edges. So build graphs. In our case, I will use a adjacency list representation of graph. So first we have to build graph, and then what we have to do, we have to have some way of keeping track of distances between 0 and node x. So we'll initialize a distance array which keep tracks of distances, and then we will start BFS of node 0. We start BFS at node 0 and then we compute distances to all the other nodes. Okay, so let's build the graph. Let me take a vector of pair of int comma int graph of n. Here, why did I take pair? Because first we represent the index will be u, and the start or this source of the edge, and in pair the first will be the destination and the second value represents the color. So the pair of int is the destination node, or the if this will be u and this will be v, and this is the color of the edge. So now let us first add the red edges. So for auto edge in red edges, we add them to our graph. G of edge of 0 dot push back edge of 1 comma. Let us define colors so that they are more informative. So let us have, we are implementing in Java. Let me change the programming language. Let's go to C++. Let me reload this. Why is it not switching languages? Okay. I think there is a problem. So let us switch by ourselves. So in C++, this will be vector of int, and this will also be vector of int, and this will be vector of int, and this will be public. So, and here we have, let me paste the code. Okay, so we are defining the color set. Let's define the colors. Private int red color is represented with 0, and blue color it's represented with 1. Okay, here we are adding the red edges, so let's take red color and then let's add the blue edges. So let me copy paste this, and we changes this to blue edges and this to blue color. Now we have built the graph. We have successfully completed building the graph. Now we have to initialize the distance array. So let's initialize the distance array. Vector of int distance of n, comma, vector of int of 2, comma, int max. Initially, I am considering infinity. So why am I taking 2? So while performing BFS, at 0, we can either 0, if we are going to some n, the path can start with red color or the blue color, and here the path can end with blue color or red color. So to represent two different distances, I'm taking here 2. So distance of 0 will represent the distance. Let's take I. So distance of I comma 0 represents distance from 0 to I with ending with red edge, because 0 means red color. So ending with the red edge. Similarly, distance of 0 of 1 will be distance from 0 to y ending with blue edge. So we considered both of them, and then we take the minimum of both, because we were asked to find the shortest path. Okay, so and we should also initialize a BFS queue. So let us initialize that pair of int comma int q. Here as well, we consider the node and then the color of the edge we are starting with, or yes, we are starting with, or we are ending with. We can consider ending with because the previous edge, and now we take what can be the next edge based on the previous edge. Okay, so q, we push source node to our queue. We have to consider two conditions, because we can start with red, we can start with blue edge. So red edge and q dot push blue edge. So here we are considering we are at 0 and we ended with the red edge. We are at 0, we ended with the blue edge. So for this condition, the next state should be the blue edge. In this condition, the next state should be the red edge. Okay, so and we have also keep track of the distances, right? Let us update the distances. Let me take it down. So let's put it down over here. And what will be the distance? Distance of 0 to red edge, red color. Distance of 0 ending with red color will be 0. Always distance at 0 will always be 0 only. So both red and blue will be 0. And we don't have to have another visited array, because we can use the distance array itself to see if the node is visited or not. If the distance of node is int max or infinity, then the node is not visited. If it has other value than int max, then it's not visited. It is visited. Other value, it's visited. If it has int max, then it's not visited. Okay, now let's start the loop while not QMT classic BFS, and then we pop the node from the front of the queue. So int node equal to q dot front. So the first will give us the value, and the second will give us the color of the previous edge. So front dot second, and now we pop that from the queue. Okay, so far so good. Now what we do? Like normal BFS, we iterate over the edges, its neighbors. So neighbor q graph of node, and this will give us all the neighbors. So let's consider neighbor node equal to neighbor dot first, comma, neighbor dot color equal to neighbor dot second. Now we got neighbor dot first, color, node and color. Now what we have to check, if we have visited this neighbor or not. How we can do? If distance of neighbor node and neighbor color is equal to int max, then we have not visited this node with, this should be colored. So we haven't visited this node with this color, with ending with this color edge. So we can go to the neighbor. So there won't be any loop. We should also check this condition, right? The edges, the edge color should alternate. So previous color is this color, and we have to check this color should not be equal to the neighbor color. If this is the case, we haven't visited this node ending at this color, so we can visit it, and we can make its distance as neighbor node of neighbor color equal to, what will be that? We get the distance to visit this node plus 1. Okay, so distance of node color plus 1, and we can add it to our queue. So q dot push neighbor node comma neighbor color, or else we can simply push neighbor. Okay, looks good. Now the BFS is completed. Now what we have to do, we have to form the result array. So let us do that. Vector of int of result, its length will be n, and we iterate over the distances. We iterate over the edges, we iterate over the nodes first, and then we have to calculate the distance, right? Before that, we have to also check for this condition if path exists or not. When will the path not exist? If both the red and the blue edge colors are infinity. So if distance of I of red color is, if this is not equal to infinite int max, or distance of I of blue color, if this is not equal to int max, if either of them exists, then distance is not, there exists a path. So distance is not -1. So distance will be, distance of I will be minimum of both, right? Minimum of distance of I of red color and minimum between distance red color and blue color. Distance of I of blue color. Okay, finally, this should be the result. Result of I equal to minimum of distances. And finally, we return the result. So the last step here is compute result array. Looks good. We have built the graph. We have initialized the queue. We have initialized the distance array. We have added the 0th edge to the queue, and we have made its distances to 0. And then we have started BFS loop. We have popped the front node from the queue. Then we have went through all of those neighbors, and we have relaxed them. We have, if the node is not visited and we have alternating color, which means the edges are not of same color, then we have considered the distance from 0 to that path by taking the distance of the neighbor node equal to distance of the current node plus 1, and we have pushed the neighbor into the queue, and we have computed the result array by taking the minimum of red color and blue color. Okay. And this result array by default should consider -1, because we have to return -1. If this is not the case, if the it doesn't exist, we have to return -1. Finally, we have returned the result array. So this looks good to me. Let us run the code. Okay, we should have another bracket over here. Let us run now. Edge of 0, push back. What's wrong? Vector of vector only, right? No matching member function for the call pushback. Okay, so here we have to build a pair. So we have to do it this way. We have to add the brackets. Let us run the code now. We have another, oh, it's not red edge, it's red color and blue color. It passed all the sample test cases. Let us submit it. It passed all the test cases. So what will be the time complexity? The time complexity will be same as the classic BFS, which is O, which will be O of n. And the space complexity will also be O of n, because here we are considering the distance array and the result array. So this is the time complexity and space complexity. That's the today's problem. So I hope you have understood the solution for today's problem. If you did, make sure you hit that like button and subscribe to Coding Champs for more daily videos.